Friends, once again welcome for part number 2, wherein we are going to discuss the converse for the corollary number 3. We have already understood corollary number 3 in part 1. In this part, we are going to understand the converse of this corollary number 3 to AA criterion. Okay, so these are the parts, figure, data part, and to prove for corollary number 3, and also proof also we have already understood. So we are trying to understand the converse of this corollary 3. You may be wondering how is that we have got two different columns for this. Oh, you must be guessing right. We have two parts, two conditions are there given in data. Therefore, we can make each one of them as the data, and to prove should become data only, so that the other one will become the to prove part. So with that idea, we can make this into case number 1 and case number 2, and these are the suitable figures for that. So in case number 1, it is said that BD is perpendicular to AC and BD square is equal to AD into DC. So we have to show that this angle ABC 90. So therefore we have not shown here angle 90. So this is case number 1. In case number 2, angle ABC is given as 90 and BD is drawn to AC such that BD square is equal to AD into DC. So we need to show that these two angles are 90. Therefore, we are not shown in the figure, and hence case 2. So therefore, we shall now write down the data part for both. So in case 1, we simply write it is some triangle ABC and never say it is a right angle triangle because it has to be proved. Whereas for case 2, we write in right angle triangle so and so ABC only, because this angle happens to be 90, that is by data. So what about the rest of the conditions? To two conditions we have to write. Okay, so let us concentrate on the to prove in corollary number 3. So BD square is equal to AD into DC is we have proved in corollary 3. So this should become the one of the condition in case number 1 and case number 2 under data. So this should go to data in two cases. Shall we do that first? Let us take a copy of this and keep it here as condition number 2 for case 1 as well as for condition number 2 for case number 2. So to prove has become data. So now data should become to prove. But we have two things here in corollary number 3 saying that angle ABC is 90 and BD perpendicular to AC. So shall we do it like this, friends? Let us take the second condition BD perpendicular to AC, and this we will make it as one of the condition for case 1, so that the other part, that is angle ABC is equal to 90 under data, should become to prove part. Okay, that we will try now. So let us take the copy of this BD perpendicular to AC and keep it here as condition number 1 for case 1, so that the condition number 2, that is angle ABC is 90, will become data now. Okay, now let us go to the case number 2 now. So let us make this condition, first condition, that is data, as data only for case number 2. So let us take a copy of that and place it here as data for case number 2, so that we will prove this BD perpendicular to AC as to prove for case number 2. So let us take a copy of that and place it here. So in other words, we have two conditions under data of corollary number 3. We can make any one of them as a data, so that the other one will become to prove. So here BD perpendicular to AC, we have proved angle ABC is 90 in case 1, whereas angle ABC is 90 in case 2 as data, and we are going to show BD perpendicular to AC. Friends, in this part 2, let us discuss only the proof for case number 1, and in part 3 we will prove this case number 2. So here we go. Yes, this is the same figure. Okay, so what would be the data? Data is in a triangle, in some triangle, not a right angle triangle ABC. We have two things. BD is perpendicular to AC in such a way that BD square is equal to AD into DC. If that is so, we have to show that angle ABC has to be equal to 90 degrees. Shall we find out the proof, friends? Here it is. Okay, now the same figure. So let us find out a square plus c square by applying Pythagoras theorem to these two small triangles which are inside the given triangle ABC. So first let us find out what is a square. Look, this is a square. A square is equal to p square plus c square. Okay, so therefore we can write for a square as p square plus dc square. And look at this triangle. In this triangle we can find out easily what is c square is equal to, which is equal to p square plus ad square. So plus p square plus ad square. So on account of Pythagoras theorem. So now we can simplify the right hand side by saying that p square plus p square is p square plus p square is 2p square, and ad square plus dc square as it is. Okay, now let us find out what is 2p square. For that, let us recall what is given in data. In data, it was said that BD has been drawn perpendicular to AC in such a way that BD square is equal to AD into DC. So, but what about BD square? BD square is nothing but P square. Therefore, we will write P square is equal to AD into DC. But we wanted 2p square. Therefore, for that multiply throughout by 2. So, therefore, 2p square is equal to 2ad into dc. So, now we have got what is 2p square is equal to with the help of data. So, substitute for 2p square as 2ad into dc in the next step. So 2ad into dc plus the remaining two terms as it is. Friends, this is one of the important step which we have to understand the right hand side of this equation. Don't you think this is of the form a square plus b square plus 2ab identity form? Therefore, it has to be equal to a plus b the whole square, which is equal to ad plus dc the whole square. Now, look at the figure. What is the sum of AD and DC? AD plus DC is nothing but AC. Therefore, we can comfortably write on the right hand side as AC square. Now, just for a while, apply this equation and look at the figure in triangle ABC. So, A square plus C square. So, this square plus this square is equal to AC square, which means that the square on longest side of a triangle is equal to the sum of the squares on the other two sides. Therefore, these two sides must contain a right angle. Do you know the reason? The reason being converse of Pythagoras theorem. Hence, we have proved that if in triangle BD is drawn perpendicular to this AC side such that if it is BD square is equal to AD into DC, then definitely angle ABC has to be equal to 90 degrees. This is what we have understood in this. So, in the next part, part number 3, we will understand the proof for the converse number 3. Thank you. Thank you.